Hi, we're Group 22, and for our ELG 336 project, we decided to build a portable computer cooling unit. We decided to do this because in order to implement water cooling to a computer system, you need enough space dimensionally and your budget needs to accommodate this. And there's not a lot of options for people using laptop computers or on a low budget to achieve this goal. The way we've decided to solve this is by the implementation of a pseudo air conditioning-like system. It uses a reservoir of cold water cooled by ice and a pump in order to move water around a heat exchanger loop. It also utilizes a fan to blow air over the cold tubing and thus cool the area of interest. Our system is made up of a pump, which you can see in the diagram, and a flow meter placed in series right after the pump to read the mass flow of water going through the cooling loop. We also have a reservoir of the cold water cooled by ice in order to extract heat from the air. Behind the loop, we have a fan which blows air over the cooling loop. This allows us to move that cold air into the area we want to cool. Maybe it's a laptop, maybe it's the desktop tower. As you can see in the working example, the fluid moves from the reservoir through the system and the fan blows the cold air out and we can cool an area. The way we've made this system smart and energy efficient is by utilizing a thermocouple. The user places the thermocouple on the area they want to cool or on the surface they want to cool. When the thermocouple reads a temperature outside of the cooling threshold, in our case we've set this at 30 degrees centigrade, the fan runs at full power and the pump moves water through the loop as fast as it can. We know from our heat transfer analysis that this is the optimal performance of the system in order to achieve the maximum cooling rate. Once the temperature starts dropping, however, we pull back the voltage given to the fan and the voltage given to the pump in order to conserve energy and maintain only the amount of cooling necessary to maintain the temperature in the range that the user has set. If the temperature is below the range that the user has set, the fan does not turn and the pump does not move. This allows us to conserve energy and ensure that the system works as efficiently as possible.